Saxon Algebra 1. I almost said 1/2. Surprise, you're going backwards. Just kidding, this is Algebra 1. We're in lesson 44. We're going to start adding, rational expressions. Rational is a fancy word that always just means fractions. And expressions means that there's no equal sign. So we're going to add fractions that don't have an equal sign anywhere in it's not an equation, it's just an expression. And I'll give you a spoilers hint, there will be lots of letters, which, as we saw in the last lesson, letters can actually make problems easier. All right, let's dive in. There's lots of problems, we're just going to plow through them. 44.1, add. I'll let you finish copying. What you're noticing as you copy the problem down is that the denominators already match. And as we know, once the denominators match with fractions, your life is easy. All you have to do is smush together the tops and then just copy the bottom, right? So this will be 4 minus 6ax over 2x squared plus y. It's that easy, gentlemen. So nice, right? Once the denominators match, you squish the tops. This next one is similar. I don't even want to write it all down. It's just a waste of our time. Look at 44.2. Look at these denominators. A squared plus 7y, a squared plus 7y, a squared plus 7y. Perfect heaven, right? Everything matches. So that means we know our answer will have this, and then we'll just combine the top, and it'll be 5 minus 3 plus z. Okay, so I'm going to write that down. What did I say? It will be 5 minus 3 plus z. That's the numerator. So then that will be 2 plus z. And then the denominator will be exactly what was in the book. It's a squared plus 7y. Okay, and I can write it here just so you see. All right, once we determined that all three fractions had the same denominator, we just added them all together with the minus signs and pluses as they were, and we're good. Number 3. Okay, I'll write this one down. But it's also similarly delightful. Oh, that's an X. Okay. So in this one, we see, once again, denominators match. As soon as I notice that we're adding or subtracting a fraction, my mind immediately goes to the denominators. Do they match? Because if they match, it's super easy. If they don't match, well, we'll see what happens then in another problem or two, all right? These match though, so that means I can just mush together the top. However, I'm gonna do it down here. I don't really have enough room there. However, this is a dangerous piece of business because this minus sign changes both of those terms. So when I see this minus sign, I quickly wrap that up in a bubble to protect it. And so now I know that my answer is going to be 5x plus 7 minus quantity 3x minus 2. Okay, super important. It's all going to be over this. The denominator, we don't need to write it twice, right? We just write it once. And then this is going to be 5x plus 7 minus 3x, because I can think of it as a minus 1 that I'm distributing, right? Plus 2. Okay, pay close attention to that. Minus 3x, and then minus minus gives me a plus 2. Okay, now I can combine the x's and combine the plain numbers. I'm not going to write the denominator again because I'm running out of room. I'll do it over here. This will be 2x, right? 5x minus 3x plus 9 over the very same denominator, 5a squared x. I almost made it plus x. Okay, that's the right answer. Okay, notice that I have been writing an equal sign just to say this is the first line and then the next line is equal to it and the next line is equal to it. In our original expression, there was no equal sign, right? Okay, that triplet, that trio of saucy problems all had the lovely feature of denominators that already match. Now we're going to deal with denominators that don't match. How dare they? But it's okay. They're fun and cute. Add 3 over 4 plus 2 over b. Okay. I promised you lots of letters. This problem doesn't have a lot of letters, but it's got a letter floating in there. So, okay, we know we're adding fractions. We know denominators must match. We look at them and go, dude, they do not match. They're not even in the same group of symbols, for heaven's sake. But that's okay. We can find a least common multiple. This is the berry basket in which we need to make sure that all the berries are represented. And we multiply the berries together. So it will be 4b. Our least common multiple is 4b. Can you dig it? Yes, you can. Okay, so now what we have to do is, and let me just, I want to rewrite this. You know how I am about writing them this way. We'll just cross that out and we'll skip over that. So we want to change both of these. We want to multiply them by a fraction that's equal to 1, and we want to end up with 4b on the bottom of both of them. So that's our LCM. Okay, so this one, I'm just looking at the bottom one first because I was already here. We better multiply it by 4, right? To get 4b. And if we do the bottom by the top, we have to do if we do the bottom by 4, we have to do the top by 4. 2 times 4 is 8. 8 over 4b is the equivalent expression. And over here, we've got the 4, we need a 4b. We better multiply it by b. Top also by b, so then we have 3b. Excuse me. So our final answer, now that our denominators match, our final answer is 3b plus 8, I'm adding right down here, over 4b. Final answer. Fabulous. We're dipping our toes into the water of adding rational expressions that don't have matching denominators. Let's do another one. And we've got, this goes up to 9 examples. Woo, doggies. Are you ready? We can do it. Okay, 4b plus 1c and 1/2. These are the 3 fractions we're adding. I'm writing them in this format. In just another minute or two, I'm going to show you a more efficient format you can start using for these problems, but I want you to understand it this way first. Okay, so first we find our LCM. Our denominators are b, c, and 2, so our least common multiple is 2bc. That's not hard, right? That's kind of fun. So we're going to multiply each of these dudes by a fraction equal to 1. And in the end, we want something that ends in 2bc. equals, right? All right. We've got the b, so we need to multiply this one by 2c. That gives us the 2bc. Sometimes I like to put a little check mark there to prove it. I checked it. And then 4 times 2c would be 8c. This one we've got the c, so we need the 2b, and 2b times 1 means it's just 2b there. Huh, all right, that worked. This one we've got the 2, so we need both letters. Again, we're multiplying by 1, so there it is. Now, everybody's got a matching denominator, and we can just add 8c plus 2b plus bc all over 2bc. Guess what? It's right. Yay. Number 6. We're slightly getting them harder and harder as we go, in case you haven't noticed. We still have a few more steps to add to our torture. I mean, it's not torture. Come on. I'm having fun. Ready? Okay, this one I'm going to do in the other format. I'm not going to do that stacky format. We don't need that anymore. 44.6. I'm going to write it down the way John writes it in the book. Okay, there are 3 fractions. The fact that there are more letters than there are numbers is not troubling. We don't care, we're tough. The fact that there's an x up here and an x down there, that doesn't matter. We just carry on, we look for our least common multiple. Remember, we're always just looking at the denominators for that. And we just pick one of each berries, right? And it will be B, C, X. Now, instead of writing out the whole thing with the boxes for the ones and all of that, we're going to take a shortcut. We know that all 3 denominators have to be BCX when we're done. This one already has the X, so we want to multiply this one by BC over BC. See how now I can see the BCX all nice and cute? Okay, this one already has the B, so we're going to have to multiply this one by CX over CX. Now, this one I wrote before, this one I wrote after. There's no significance as long as it's next to it and it's just wherever I have room on my page, all right? And then over here we've got the C, so it's gonna be BX over BX. That's the shortcut for documenting this, all right? Now I'm gonna go through and I'm gonna write these in order. I want everything in alphabetical order. That is such a big help as we're getting these more complicated problems. 5BC plus CX squared, we're multiplying these, plus ABX all over BCX. Dun, 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 dun. John didn't put his in alphabetical order, but that's his weakness, not mine. That's the right answer. If the letters are rearranged in the clumps, the terms, it's fine. They just have to be there and the signs have to be right. 44.7. All right, well, this one looks a little confusing because look, we've got exponents in our denominators. All right, we'll figure that out. And then what about this floaty dude? Well, that's an easy one. Give him a denominator, get him in the fraction club. Ones are easy, we can deal with it. Least common multiple. If you need a little help, let's basically remember how to prime factor these, right? This is C times C times C. This is C times C. So our least common multiple is going to have to be the highest exponent, right? We talked about that. The one with the highest exponent. We need 3 C's. He can find himself in that berry basket. We're good. I'm going to cross this out so I don't confuse myself. So our least common multiple is c cubed, c to the third power. This one is already there. Check, it doesn't need to be adjusted. It's beautiful. This one is c squared. We need to multiply it by one more c, don't we? So that this will have 3 c's. And this poor guy, he's got nothing. So we have to do c cubed over c cubed. Make sense? Now we have m plus 4c minus 6, c cubed all over c cubed. Do you like it? I do. I'm pretty chuffed with myself, or the problem really, not so much myself. Okay, 2 more. $44.8. Sometimes I understand exactly why John chooses the example problems that he does. I can see how he's slowly building toward, he's adding a degree of difficulty with each additional example. But sometimes I'm just like, John, you went crazy on this one. This is a lesson where I think he went a little crazy. All right, p over x minus a over 2 plus c over b. This one I'm going to have you do by yourself. Find the least common multiple, adjust each fraction, add them together, and then when all of you are done, try to do it on your own. You can help each other if you need to. Well, you guys don't watch the videos together, so I guess that's going to be hard. But give it a shot, and then play me again, and I will do it, and you can check your answer. Okay, so pause me now. All right, you're back, so I will carry on. Yes, I think I can't talk. I can talk. 2 goes into the 4. So if I make the least common multiple 4, 2 can find himself in that 4. That's fine. So my least common multiple is 4b. This one I do by b over b. This one I need to do 2b, right? And then when I multiply, I'll get 4b. And then this one is 4 over 4. Okay? It really helps to use another color. And if I can't convince you to keep another color pen or pencil close by, just spread out so you have lots of room to squeeze that in. All right, alphabetically, BP minus 2AB plus 4C all over 4B. Double checking, yes. And here comes our last one, ready? Okay, try pausing me and working it. Play when you're done. You're back. I'm working on the number first. You may quickly see, oh, 4 times 3, the first number they're going to both go into is 12. But if not, you can break it down to prime factors, right? I'm going to need a 2 times 2, and then I'm going to need a 3. So that's all of those, and that will equal 12. And then I'm going to need the largest exponent. Oh, you know what? I confused you if you did it before. This is a C. I'm sorry. I just probably aggravated you badly. C to the 4th. I want the biggest one, right? So, C to the 4th, so this one has to be 12c squared. This one has to be 3c, right? The missing pieces that I need in order to turn that into that, I'll need to multiply by 3, and then I'll need one more c. And then this one, it just needs a 4 over a 4. Make sense? Now I'm going to multiply and reorganize each term. This will be 12ac, that's a squared, right? Yes. Plus 9c plus 4m. And all of that is over 12c to the 4th. I'm really sorry that I wrote the problem wrong and didn't catch it until after I told you to try it. Don't be mad at me. But that was really messed up because I gave you a problem that was much harder. Now you understand, and I hope that you won't hate me forever. Okay, that is the end of lesson 44. You guys, this is a huge advancement in our algebraic journey, and it was kind of a rigorous lesson, but we're gonna get lots of chance to practice it because we'll be doing this forever and a day. All right, that's the end of 44. Farewell.